So in this tutorial, I'm going to go over 5 Swift features which I consider must-knows. And they are lazy vars, then we'll look at tuples, Swift arrays, look at the updates to enumerations, and then look at a new type of property called computed properties. So let's go. Okay, so the first thing we're going to look at are lazy vars. So here's an example of a simple iOS project, and inside of the main view controller, I'm going to use core image to essentially, let's say, apply a CI filter to an image, and then I want to use a CI context to actually draw it. And here, what you would typically do is I'm creating a class property called context of type CI context. In the view did load, I'm essentially initializing and instantiating this. So I'm going to be drawing to an OpenGL surface. So I create my eagle context and then pass that into the constructor for CI context. Now, this is fine and it will work, but the thing is, creating and initializing a CI context is an expensive operation, and I'm not going to need to actually use the context until maybe the user taps on a button to apply a filter. And here you can see an example draw image function where I would actually use that context. So what I would like is to have the CI context initialized only when I need it or when it's first called. And to do that, we use lazy vars. So what I'm going to do is to get rid of this line. And here we're going to create a lazy var using the lazy keyword. So lazy var context of type CI context is equal to, and then we open some brackets, and then we need to put a set of empty parentheses, so this is actually executed when we call it. And now inside of here, I can initialize this CI context. So I can take these 2 lines here, which were previously in view did load, paste them in here, and now instead of setting the context here, I just need to return this. So now what's going to happen is when I first come into my view and my view controller, I'm not going to be instantiating that CI context. Only when, let's say, the user taps on applying a filter and this draw image function is called, will the CI context actually be initialized. So tuples allow you to group a set of values together and treat them as a single type, essentially a compound type. And the main use for this is in functions. So let's say I wanted to return multiple values from a function instead of just a single value. Well, I could use a tuple, and we'll look at that use case in a second. But let me just look at it now at the simplest level. So let's say I wanted to create a variable which contained my body weight. So I would say var weight. But let's say that there's 2 values I wanted to store. First is the actual numerical value, and then a string representation of how it should look printed out. What I can do is to create a tuple by opening parentheses and simply putting in the 2 values. So first the numerical value, and then putting in 214 lbs as the string representation. So that I've now created a tuple. And this is, again, 2 different values, and these can be of any type, but I've temporarily grouped them together into a tuple. Now let's say I wanted to access a specific value in this tuple. Let's say I wanted to just print it out. Well, I could say weight, and then they're actually indexed. So each item in the tuple is indexed. So I could print out weight.0, and there you see 214, and I can do weight.1. And there we can see the string value. Now let's say I wanted to extract a single value from here and assign it to, let's say, a constant. Well, another thing that we can do here is to create a constant and then essentially open parentheses. Now for the value that I don't actually want, I have 2 values here. So any that I don't want, I just put underscores. And then for the value that I want, I'm going to put in my constant name, and I'll just call it weight str for weight string, and set that equal to weight. And now if we simply print that weight string, we can see we've extracted that string properly. Now, you wouldn't ordinarily do this. Tuples, again, are typically for temporarily grouping values together, but this is what a tuple is in its simplest form. But let's look at an actual real situation where you're creating a function that returns multiple values. So what I'm going to do is to create a function, and I'm going to call it string info, and we're going to be sending a string as a parameter to this function. Now what I want to return are two values, so I'm going to create a tuple return type, and what we're going to be returning are first an NS array of all of the words that were actually in the string, and then we secondly want to return the number of times that the word the was found in the string. So I'm just going to create another property here called num, and this is going to be of type int. So now I've defined that I'm going to be returning two values, an NS array and an int, combined together into a tuple. So let's actually make this work. So I'm going to create a constant called words, and we're going to go to that string and call the components separated by string, and the string is just going to be a space like that. So that's going to get us our array of words. Now I'm going to create a var called num and set it equal to 0. And we're going to loop through those words. So for word in words, and we're going to say if word is equal to the num plus plus. And now we can return those two values together. So return, and again, we're going to create our tuple return type, words, num, like that. Okay, so now that we've created the function, let's go ahead and use this. So I'm going to come under, and I'm going to create a constant, and the constant is actually going to be a tuple. So we're going to set two values here, words and num. So now we're actually going to call the string info function, and I've just have a paragraph of text, of long text copied to the clipboard here, and we're passing that in. And you can see immediately the playground is showing me that it found the word the 8 times, and it actually returned the array of all the individual words. I can now access them individually. So here I can say num, and here you can see the value 8. So again, this is the most typical use case of tuples, is being able to return multiple values grouped together from functions. So in Swift, many of the foundation classes that you're used to using, for instance, NSArray and NSMutableArray, have new, more powerful types in Swift. And we're going to look at Swift arrays. So with an NS array, we could combine multiple types in a single array. I could have an image, a number, a string. Swift arrays are type strict, meaning they can only contain one type of value. And they're always mutable, so there's not like a mutable and a non-mutable version. So how do we create a Swift array? So I'm going to create a variable called r, and the first is just using literal syntax. So I can just say 1, 2, 3, 4, and I now have a Swift array with those values. Now, if I want to actually be a little more formal, I can actually open up square brackets, put in the type, and then use the open parentheses, and that now creates a Swift array of type integer. Now, to add values to it, we can use the append, and I can simply put in the value 10. And we can see now we can add items into the array. Now, there is an even more formal way of writing this, which is to say array, and then in angle brackets, put the type, and there essentially we're creating the same exact thing. So again, those are the different options for initializing. I'm just going to go back to 1, 2, 3, 4 like that. So here I've created a Swift array that has 1, 2, 3, 4. Then I've appended the value 10 in there. Now the other thing that I can do is to use the plus equals syntax to essentially combine another array into this array. So let's say I wanted to add to my array the values 45, 6, 89, 7. So here I'm essentially creating an array and I'm appending it or concatenating it with my original array. And you can see in the results panel at the right that those two things are combined now. So now if we look at some of the properties and methods on Swift arrays, we have array.first, which will give us the first element. Array.last will give us the last element. Let's say we want to remove the last element. There's a remove last method, which is a time saver since we don't have to be checking the length and things like that. We can also replace a range of values in the array using the new range operator. So I can say R, and then let's say I wanted to replace the first through the third values in there with a new array of values. So let's say 1, 23, 5, and 3. And now if we actually print out our value, we can see that those values have actually been changed. So we can change an actual range of values. But let's say we actually wanted to create an array with a defined number of elements. What I can do is create another variable here. This will be R2. And let's say I'm going to create of type int. And what we can do here to this constructor is to pass in a count value, which is the number of elements in the array. So let's say 20. And one of the handy things here is we can actually set a default value for all of these. So let's say we wanted to set the default value for all of these to 50. So if you look here at the right, we've now created a Swift array with 20 elements, all have the value of 50. So those are some of the powerful features that you get with Swift arrays. So enumerations have been updated quite a bit in the Swift language. So when we created an enum in Objective-C, each value in that actually was backed by an integer value. Well, that's no longer the case by default in Swift. So if I create an enum, and let's just call it corners, to create it, I'm going to open up some brackets, and to define each value, we use the case keyword. So case top, case bottom, case right, and case left. So now each of those values is an actual enum value type. It's no longer backed by an integer. So if I actually look at one of those values, let's say corners.right, we can see here in the value panel actually says enum value. Now let's say that we wanted to actually have these enum values be backed by integers. To do that, we actually give the enum a type of int. And now what we're going to do is to take that first case statement and set it equal to an integer. Now if we don't set a value for the others, it'll automatically be incremented. So bottom will be equal to 2, right, 3, so on and so forth. Now to actually get to the integer that's backing the value, all we have to say is raw value, and that's going to return us the actual integer that's backing this value. Now we can also go the other way. We can get the actual enum value for a specific integer, and to do that we say corners, and here we're going to actually pass in the raw value for the value that we want to get. So let's pass in 3, and that will now contain the value corners.right. And we can make sure just by seeing if it's equal to corners.right, and it is. So again, with this raw value, we can both get the raw value and we can retrieve the enum value from a raw value. Now the raw value doesn't have to be an integer. You can use other number types. You can also use strings and characters. So now that I have this created, I'm going to come down here and I'm going to create a variable, and I'll call it corner. And I'm going to set it equal to one of those enum values. Let's say corners.left. So now I've actually defined this variable, and the variable knows that it's of type corners. So later on, anytime I want to use or assign a new value to this corner variable, I can say corner is equal to, and I can simply use a shorthand syntax saying .right. I don't have to write corners anymore because, again, the context has been set and it knows the enum type is corners. So this is a time saver, especially in things like switch statements. So another thing that we can do with enums now is to associate values with an enum value. Let me show you how that works. So let me just get rid of this. So I'm just going to recreate this enum. So enum corners. And let's say I'm defining the right case. Well, I can actually associate data with this enumeration value by opening parentheses and pass in any number of different types. It can be any types and any number of them. Let's say I want to associate a CG point with this enum value. Now when I create a reference to that value, so let's say var corner is equal to corners dot right, you can see it's asking me now to pass in a CG point. So I'll just pass in CG point 0. So now we've essentially gotten a reference to that enumeration value, but when we've created a reference to it here, we've attached some associated data to it. And this introduces some new interesting ways in which we can use enumerations. So in Swift, we have a new type of class property, which is called a computed property. And these are interesting in that they don't actually hold any values themselves. You actually use them to set the values of other properties and variables. So here I've created just a simple playground. I have a UI view subclass called myView, and I have an instance of it created here with a width and height of 200. So what I'm going to do is to create a computed property called size, and this is going to be of type CG size. So to create the computed property, we're going to open up some brackets, and now we need to provide a getter, and we can optionally provide a setter, which we're going to do. So we're going to say get, and then we're also going to provide a set by saying set. So now for the getter, all I'm going to do is to return the size of the bounds of my view. So I'm going to return bounds.size. Now when this property is actually set, what we're actually going to do is to change the size of my view. And this is going to be a nice quick way to change the size or the frame of my view. So in the setter, I'm going to get a reference to the current frame for my view. And I'm just going to call it f. And then I'm going to say f.size is equal to, and now we want to get the new value which has actually been set on this computed property. So to get that, we actually use the new value property. Now we can optionally define a name for it. So we can give some parentheses, and let's say we want to call it new size. We can actually come down here and say new size. So now I've essentially set the size of this variable, this CGRect variable. Now let's go ahead and actually set it as the frame for my view. So now if we come under here and say view.size is equal to CG size make, and we'll pass in 400 and 400. And now if we look, here's a preview of my view originally, and then after I've set that size computed property. So you can see now, just by setting this one property, it's essentially gone and updated the frame size. So again, computed properties themselves don't store values. They're actually used as a method to update other values.